Welcome to Easy Math TV. We're going to continue our discussion of statistics, and specifically, this is the playlist on continuous probability distributions or continuous random variables, and specifically the normal distribution. We already created, in a previous video, we created the normal probability distribution or the density curve and probabilities associated with it on this random variable x that was normally distributed with a mean of 65 and a standard deviation of 4.24. But I realized that we didn't talk about z-scores, and z-scores are just associated with the normal distribution. Like, that is just an automatic association. So we need to make some sense out of what z-scores are and how to calculate them and what do they mean, what do they give us. So in front of us is these are our x's that are calculated from our given information. So all we know is that the mean was 65, so I placed that here in cell H4. I just typed that in. It's not a formula or anything. That's my mean. And deliberately, it's right in the middle because we want to see what happens to x values as they get farther and farther and farther away from the mean. We want to see what happens to them. We saw a graph of the probabilities and how it kind of trails off. It starts with the highest probability right here in the middle and kind of trails, gets less and less likely the further away from 65 you get. That's just the definition of what a normal distribution is. The value of sigma is 4.24, and again, I decided to divide that in half because I wanted you to see like all these different values of x that are 2.12 units away from each other, and then like what their percentiles will be, as well as what is their associated z-score. So a z is just another random variable, and it measures how many standard deviations from the mean you are. Okay, that's what the z-score does. So again, if you didn't see my previous video showing where these numbers here came from, you might want to take a look at that. That explains where we got the 67.12, the 69.24, 71.36, and so on. Basically, we just get them by you keep adding 2.12 to the right, and you keep subtracting 2.12 to the left from the 65. So you start with 65, and you add 2.12 going to the right, you subtract 2.12 going to the left. But if you want to see how I actually created that, take a look at the previous video, the two-parter on that. So this is a number line that shows my x's, and again, the farther away from 65 you get, the less likely they are. Since there is really no limit on these numbers, theoretically you could keep going. Like, you could go all the way further down past 52.28 to the left, or beyond 77.72 to the right. Those numbers, however, are extremely unlikely for this distribution. So we're going to just use those numbers and consider how we can find their associated z-score with those x's. So it starts in row 7 down here, where we have to calculate their percentiles, their probabilities, because we need to be able to, if we want to just get a z-score, the z-score calculation is equals norm.s.inv, and you have to give it a percentile. You have to give it a probability to get the z-score. So we need to calculate those here. All right. So step one to getting the z-score associated with a particular value of x is to calculate the percentile. So starting with cell B7, because I'm going to start all the way here, and then I'm just going to fill to the right. We're just going to click on that anchor and fill to the right. So we don't have to type in this formula again and again. Just type it in once. So down here in cell B7, underneath the number 52.28, type equals norm.dist, norm.dist, parenthesis, and we're going to just put the B4 there, and that's not a fixed reference because that's going to update as we go to the right. But the next two numbers are fixed references, comma, and this time I put the we have the mean in H4 that hasn't changed from the previous videos. So the mean is $H $4, comma, but I moved the standard deviation because it was in the way. So I moved the standard deviation up to cell A2. So right after H $4, comma, you will put $A, $2, comma, and then the word true, and then close parentheses. So it has to be exactly in that order. And the first number you should see here is 0.0013. So that's telling us that anything to the left of 52.28 only has a likelihood of less than, well, it's about 1.3 or 0.13% chance. 0.13% chance. So less than a percent chance of anything to the left of 52.28 happening. So that means that anything to the left is going to be really rare, really rare. And you'll notice that these numbers just keep going up as we go left to right because those are cumulative probabilities. Those are your percentiles. So if you click on the anchor in the lower right corner of B7 and just fill all the way to the right, the last value here under 77.72 has a percentile of 0.9987. And we expect this to happen. The mean itself should have a percentile of exactly 0.5 because it's exactly in the middle. Okay. And then the value 69.24, which happens to be one standard deviation away from the mean, that's anything that's mu plus sigma is always going to have a probability of 0.8413. That's just the nature of the normal distribution. These probabilities that you see here are tied to the fact that these numbers in row 4 are a certain number of standard deviations away from the mean. Okay? That is important. So to get the z-score now, I'm just going to type equals, and it's norm.s.inv, open parenthesis. And notice you'll see a little bit of a help there. It's looking for a probability. So I'm just going to copy the probability from B7. Close parenthesis. And you'll notice that that's giving me a z-score of exactly -3, which, and directly above that, we see that the number 52.28 is the mean minus 3 times the standard deviation, minus 3 times sigma. So the -3 is the number of standard deviations away from the mean we are. So I also want to increase the number of decimal places included on that z-score. It doesn't have to be quite so big though. Just one whole number plus 2 decimal places is enough. And now we can just do a fill right. Fill that all the way to the right. And just notice notice a pattern there with the z-scores. That's all I want you to do, is notice a pattern. Let's pick a fill color that's kind of different. There we go. So the pattern of z-scores that you see counts how many standard deviations away from the mean you are. And you know, we chose our x's on purpose to be multiples, like increments of half of a standard deviation away, because we divided sigma by 2, remember. Sigma divided by 2 was 2.12. So each of these numbers is half of a standard deviation farther along on the x-axis, on the x interval. So minus 0.5 z-score is exactly minus half of a standard deviation away from the mean. 62.88 is half of a standard deviation to the left of 65. And that's what the z-score is representing. It's telling us exactly how many standard deviations from the mean we are. Like, subscribe, comment down below. Make sure you share these videos with other people who you think might find them useful. We're going to probably move from this series into some inferential statistics and confidence intervals and hypothesis testing. So stick with me, and I hope you enjoy these videos. See you in the next video.